Next 6 questions, starting with number 13 from your last benchmark. Let's take a look at these today. A student makes a model of 4 different waves and labels them wave 1, 2, 3, and 4. Which wave in the model has the lowest amplitude? Amplitude, remember, is from the middle to the crest on either up or down. You can go the crest or the trough, the highest point or the lowest point. You start at the middle and you go to the top. So which one has the lowest amplitude? So we're looking for the wave that's the smallest, and that's wave 3. Wave 1's small, but wave 3 is a little bit smaller. So the lowest amplitude would be wave 3, okay? Amplitude is like energy or volume, and the higher it is, the wave goes, the more energy it has. Okay, number 14. The coast of the Gulf of Mexico has changed over thousands of years. So we've got 6,000 years ago, that's what it looked like. 1,000 years ago, this is what it looks like. Today, this is what it looks like. A student claims that the change in the coast is due to deposition from the Mississippi River. Which statement supports the claim made by the student? Well, we look up here, we see it Mississippi River. I didn't see that. So this is the Mississippi River, Mississippi River. So which statement supports the claim that the Mississippi River is depositing sediment in the water there? The Gulf of Mexico and the Mississippi have increased in size? No, they've gotten smaller, haven't they? They've got more land, less water. The Mississippi River has changed direction away from the Gulf of Mexico? No, it's still flowing right down into it. The number of river channels meeting the Gulf of Mexico has increased. The map doesn't show that, does it? The land mass where the river meets the Gulf of Mexico has increased in size. So yes, it's going to be D. So as the river flows down through here, it's dropping more sediment, Okay, so the land has increased because the river is taking dirt and things that's washed into it and depositing them in the water. So the land mass has increased. So the 14 is D. 15. Soil is made of tiny rock particles. These particles have small spaces between them, and bacteria live in these spaces. How could an increase of bacteria in the soil affect the area? Well, now let's go back and reread this. Soil is made of tiny rock particles. These particles have small spaces between them. Bacteria live in the spaces. So there's more bacteria. It's an increase in bacteria living in the particles in the dirt. An increase in bacteria growth will decrease the amount of soil. An increase in bacterial growth will break up the soil. An increase in bacterial growth will direct the flow of water to the soil roots of the plants. An increase in the bacterial growth will slow the flow of water in the soil. Well, so it looks like this is a tough question. This is a really tough question. So this is not something we've covered. We've just got to think through this one. In the spaces in the soil, there's bacteria. So imagine, okay, think about erosion with me. So you've got to, let's compare it to water getting in the crack of a rock. Okay, so that water gets into the crack. If there's more water, what happens? The rock would break apart when it freezes, right? So if there's bacteria in these little cracks in the soil and we add more bacteria, what's going to happen? It's going to break up the soil. So that would be answer B here, because it's in the spaces between the particles in the rocks. This is a tough question, guys. It's kind of a weathering question about bacteria and rock particles in the soil. So that's a toughie. But we've got to think through them, and so that one's going to be B. All right. Use the information, answer questions 16 and 17. So let's scroll down a little bit. Oh, no, what did I do? There we go. 16 and 17. All right, so a student places an arrow on a string of a bow, stretches it backwards, and releases the string. So he's shooting a bow and arrow at the target. When is potential energy increased? Okay, remember potential is not moving. So he's going to have, it's like a rubber band. Remember we use our rubber bands to show potential energy. So when he pulls the string backwards and holds it, looks like the right answer. Let's read the other answers. When the student aims at the target, aiming doesn't do anything. When the student lets go and the arrow flies, that's kinetic energy. When the student walks to take the arrow out of the target, that doesn't have anything to do with it. The answer is B. Like potential energy is the ability, stored energy. When you got the arrow pulled back on that string, it's got the potential, if you let it go, to go flying. So it's going to be B. 17. When the student sees the arrow move in a forward direction and hit the target, at what point does the potential energy of the string change to kinetic energy? Well, kinetic energy is what? The energy of motion. So we're looking for it moving. When the arrow hits the target, it's not moving then. When the student holds the bow in the air, no. When the student places the arrow on the string, no. When the string is released, that's when it starts moving, right? So 17 would be D. Kinetic energy is the energy of motion. So when you release that string, and it's going to move, the arrow is. Last one for today, number 18. A model of a mountain is created with clay. Water is poured over the top of the mountain. The water causes small balls of clay to form at the top of the mountain. As the water flows down the mountain, the small balls of clay flow with the water and collect at the bottom of the mountain. Okay, so we're pouring water, and then little balls of clay form, and they roll down the mountain. That's a weird question, isn't it? Okay, what can be learned from this activity? Don't pour water or you make a mess, right? Well, let's see what the answers are. Only rivers cause weathering of Earth's materials. Only rivers cause erosion of Earth's materials. Rivers cause weathering and erosion of Earth's materials. Rivers do not cause weathering and erosion of Earth's materials. All right. You could about forget the silly example they gave us and just think about which one of these is true. Rivers. As a river flows along the side of the bank of the river, it's going to weather it, right? It's going to break it down. And as that dirt that it pulls off the side of the river gets into the water, then it's going to be eroded. It's going to carry that dirt, right? So rivers cause weathering and erosion of the Earth's materials. This example wants you to see that if you're pouring water over this, it's breaking apart some of the clay on the top of the little mountain that you made, and then it washed down the mountain with the water. So that's weathering and erosion. So this one is letter C. Kind of a silly example, but I guess you can understand that. All right, we've got a couple more days of this. Got some questions for you to do today. Go give them a shot.